Welcome to Link G4x Training Part 23. In this video, we're going to be taking a look at working with our spark timing and our spark timing modifier tables. Now, our spark timing is going to be when we command the spark to actually happen during our auto cycle. It's very important that we have the proper spark timing so the engine is going to be performing as we'd expect. If our spark timing is too advanced, we could damage the engine. If our spark timing is too late, we're going to find that the engine is going to have lackluster performance. It's going to be sluggish. So we need to understand how to program the values within our main spark timing table based on the engine configuration that we're working with. We're going to be taking a very basic approach in the beginning of the video, taking a look at the spark timing and breaking down how it relates to the auto cycle so we can visually understand what the values represent in the table. And then we're going to go through and build out a basic table so you can see what kind of values you can start with for any kind of engine, learning how to scale our tables, learning how to do some editing techniques within our spark timing table, and then finally taking a look at our spark timing modifier tables, our intake air and our engine coolant temp tables. Those are going to be modifying against our main spark timing table so that if we have really hot coolant temperatures or really cold coolant temperatures or really hot intake air temperatures, we're going to make sure that the spark timing is going to be offset and deliver properly to the engine to avoid any kind of issues or engine damage. So without further wait, let's jump into this video so we can check this out. Okay, so let's get started. We're going to be taking a look at working with our spark timing and spark timing modifier tables within our PC Link software. We have to understand what's going on with our spark timing to properly calibrate our engine. If the spark timing is going to be too advanced, we run the risk of having too much cylinder pressure and as a result having knock or pre-ignition occurring. We can damage the engine. If we have our spark timing too late or too retarded of a value, we'll be losing torque and horsepower, and we'll find that the engine isn't going to perform optimally and it's going to cause the engine to run sluggish. We want to avoid that. So we want to find the balance or the sweet spot of where ignition timing needs to be at so the engine's going to run correctly at all operating conditions, from idle, part throttle, even into wide open throttle. So the first thing we're going to do here in this training tutorial is take a look at the spark timing table and how the values relate to where we're commanding the spark timing so we can understand things conceptually so that the values in the table are going to make a bit more sense. So we're going to move from our basics page and jump into our spark page. Within our spark page here, we're going to find that we have our ignition table 1. This table is where we have the spark timing commanded from. So we can see the table here is three-dimensional, just like our main fuel table. And we can find the load axis of the table here is usually set on map pressure, not on MGP. So the fuel side of things relates to our barrel pressure and the map pressure in our MGP axes on our load scale. But in the spark timing, we can usually just reference it based on map pressure alone. We don't need to have MGP as our load axis. And in fact, none of the base maps from Link are going to have MGP on the load axis of the spark timing table. Now we can change this from map to throttle position if we're in alpha N mode, but typically we want to leave it on map pressure on almost all circumstances. The top scaler here, this is based on engine RPM. So we have load versus engine RPM, and the values within the table are where we want to command the spark to happen. So if we're programming a value of 14 degrees, it's going to be tracking the cylinder position within the link. It's going to be then sending the spark to the spark plug to be able to initiate the spark at that particular location right here of 14 degrees. Now we can see the values, if we're looking at idle, are low, so 10, 14, 20 degrees. As we start to drive, the values ascend here. They're getting higher in the part throttle cruise area in operation. And then as we get into the higher load, wide open throttle areas here, the timing starts to reduce. And it's all going to be a result of controlling our combustion pressure and temperature so that the engine's going to perform optimally and avoid having knock or pre-ignition. So let's go in and talk about the values within the table here, and then we'll bring some visual aids up onto the screen that are going to let you understand exactly what's going on here with the values that we're programming so make a bit more sense. So if we're looking at our values here of something like 37 degrees, this is going to be commanding the spark to happen 37 degrees before top dead center. So a positive value here is before top dead center, and the top dead center position is going to be between our compression and our combustion stroke. That's where the piston's actually going to be at TDC. So if we had a value in the table here of 0, that would be commanding the spark to happen at TDC between the compression and combustion stroke. 37, 39 degrees, we're initiating the spark timing 39 degrees before the piston gets to top dead center. So in this case, 39 degrees before top dead center on our compression stroke. And then we can find if we have a value here, 4 degrees, it's a much lower value, much more retarded value. That's going to be then commanding the spark to happen 4 degrees before the piston reaches top dead center on our compression stroke. And we have a negative value in the table. Let's just change our value here from 4 to -4. In this case, we're going to be commanding the spark to happen when the piston starts to go into the combustion stroke. Now the combustion stroke is going to, or the power stroke is going to be where the combustion actually happens and then the pressure and the mixture that's going on in the combustion chamber, that combustion is going to be pushing down on the piston, and then it's going to be pushing the crankshaft and building the torque and horsepower of the engine. So depending on what kind of values we're placing in the table here, we're essentially telling the link where we want the spark to happen, and then being able to control the combustion process within the engine. So we can see lower values, these are known as late combustion or retarded values. Higher values are known as more advanced values. And we'll find kind of the average value, if we're looking in any spark timing table, is going to be between 15 to 20 degrees when we're below that, or retarded values. When we're higher than that, we're more advanced values. So we can see part throttle here has higher advanced values. As we go up in load, we find that the values start to decrease or get more retarded or later in combustion. And then as we go up in engine RPM, usually we'll find that the values are going to ascend. They're going to get higher as we go up to the table. So that should make sense of kind of what we're talking about here within the values that we're programming in the table. Now, to better understand this, coming up on the screen is going to be a video of the auto cycle. We can break this down just so we can see conceptually and visually what is going on as we program the values in our table. So what we're going to find here is the auto cycle starts off in our intake stroke. Our intake valve opens, we allow the fuel and air mixture to come into the combustion chamber. The piston is going to draw from top dead center. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.